Hello everyone, my name is Devashish Roy. I am the Senior Network Analyst at the Indian Cybersecurity Solutions, and I welcome you all to this special webinar today. And today's topic is a very important one, that is the EIGRP routing protocol of the Cisco Enhanced Interior Gateway Routing Protocol. So EIGRP was for a long time a Cisco proprietary protocol, but it is now open standard, but it was a Cisco proprietary protocol for a long time. So we'll discuss about this protocol, what are the features of this EIGRP, how is it different from the other protocols, and so let's begin with the theory first. So EIGRP will give a detailed overview of this protocol and will focus on its definition, key features, operational mechanics and configuration. So what are the different features of this EIGRP protocol and how is it different from the other protocols? So EIGRP is an advanced distance vector routing protocol developed by Cisco, and sometimes it is said that it is hybrid routing protocol because it has some features of link state routing protocol, which has the entire picture of all the say routers in its network, and also the distance vector routing protocol. But it is safe to say that it is advanced distance vector, do not use the word hybrid. So it is used to facilitate dynamic routing definitely within an autonomous system. As we know that autonomous system is a bounded area, it is a logical area within which the routers reside and they share the routing updates. It is similar to the OSPF, but it is different also. Like in the OSPF you see the areas. So the autonomous systems are divided into areas, but in case of EIGRP it is not. What are the key features? EIGRP boasts several key features including efficient use of bandwidth through partial updates, because it sends the partial update, not the full update. As we know that in case of OSPF it is either the full update or the incremental update, but in case of this EIGRP it is only the partial update. So it does not do the LSA flooding that you have in the case of the OSPF. Now it supports for multiple network layer protocols like the IP, IPX, all these protocols are supported through the EIGRP's. Say there is a feature known as the protocol independent module, bounded updates and rapid convergence times. So yes, it is also converged or synchronizes very rapidly, and EIGRP is the fastest protocol you can say. Now comparison with other protocols, EIGRP differs from other routing protocols like OSPF and RIP due to its hybrid, or so to say as an advanced distance vector nature. Now OSPF is a purely link state routing protocol and RIP is a pure distance vector routing protocol, and it actually combines both. Now which allows for quicker convergence and more efficient routing. Now like the link state, if you ask me, like the link state, it actually maintains three tables like the topology table, like the neighbor table and the routing table. And also like the distance vector routing protocol, it shares the updates with the neighbor routers. So it does not have the complete picture of the other router updates. So it is like the distance vector, and also it maintains the databases separately, that is like link state. So it is having the features of both routing protocol. Now in case of EIGRP operation, routing table updates, EIGRP utilizes a routing table definitely that dynamically updates itself based on the EIGRP topology table. So topology table is that which is having the entire network, entire view of the network. So you are having 100 routers. So maybe it is in different A's, but every router will be in the topology table. Now which contains all the routes learned from neighboring routers, efficiently managing incoming and outgoing traffic. Then neighbor discovery. Now EIGRP say discovers neighboring routers using the hello protocol. Like the OSPF, EIGRP also has the feature of the hello protocol. Now which regularly sends multicast messages, and what is the address? It is 224.0.0.10 to establish and maintain relationship with adjacent routers. So like the say the OSPF, EIGRP also sends a hello protocol to discover its neighbors. Now the data exchange process, EIGRP exchanges routing information through route update messages. Like the OSPF, and these updates are sent only when changes occur. Like when the changes occur, only then say the multicast is sent, not the broadcast, and minimizing unnecessary traffic and conserving the bandwidth. Now, what about the configuration? To configure EIGRP, you can start by enabling EIGRP on router using the router space EIGRP and the AS number in the global config mode itself. Now, then define the networks to advertise by using network and network address. You have to advertise the local network, that is directly connected networks, not the say the destination network. Now, there are some advanced features of the EIGRP before we start configuring it. EIGRP supports features such as route summarization. When you summarize different routes like different say Ethernet ports or loopback interfaces, you are say having 10 loopback interfaces you are summarizing. Then load balancing, these are used for the conservation of the CPU, and the use of metrics like bandwidth, delay, reliability and MTU for better route selection. But by default it is bandwidth and delay. By default these are the two metrics. As you know, these are the K5 metrics, 5 K values, but EIGRP uses by default bandwidth and it can use delay also. It is a composite metric. Then what about the troubleshooting tips? To troubleshoot EIGRP, check neighbor relationships using the show IP EIGRP neighbors. If you have found that it hasn't made any neighbor relationship with the neighbors, just find it and troubleshoot it using the show IP EIGRP neighbors command. Verify routes with the show IP route definitely, and monitor logs for any inconsistency. Now, about the performance metrics, convergence times, it is definitely faster, that I have already told you, compared to other protocols due to its efficient algorithm. So, algorithm is a dual diffusing update algorithm. This is the algorithm it is used to send the partial updates. And bandwidth utilization, EIGRP is designed to optimize bandwidth usage by sending updates only when necessary, and as you know that metric here it is the least bandwidth. It uses the least bandwidth among all the bandwidth of the links, and it uses the bandwidths definitely wisely. It uses the bandwidth, and which helps to reduce unnecessary traffic on the network. Scalability also, EIGRP is scalable in large networks as it can support up to 255 equal cost paths and thousands of routes. Not only equal cost but unequal, that is the main thing, that it can do load balancing in unequal cost path, but not in the case of OSPF. In case of OSPF it cannot do, but EIGRP can load balance across maximum 6 unequal cost paths. That is very unique in this protocol. In case of security aspects also, EIGRP supports authentication like the MD5 and plaintext authentication. It is also supported in other protocols like OSPF, and EIGRP also supports that, which can be used to secure routing updates. But there are some common vulnerabilities also in case of EIGRP, include exposure to route spoofing and potential DOS attacks. So this is very common in the other types of say routing protocols also, the spoofing attack like MAC spoofing like that, and potential DOS attacks. The proper configuration authentication also will mitigate this risk. And best practices, you have to follow the best practices for EIGRP configuration, including authentication, implementing route summarization to actually lower the pressure on the CPU, and regularly monitor routing updates for optimum security and performance. So these are the things there in the EIGRP, and we can conclude that EIGRP is a powerful and it is a very efficient routing protocol, and it is suitable for modern environment, fast convergence, bandwidth efficiency, scalability, all these things. So EIGRP definitely, it was a long time, it has been a very preferred protocol for the network engineers, but the problem was that it is Cisco proprietary. So only on Cisco routers you have to configure the EIGRP, but nowadays say for about 5-6 years it is now vendor neutral. So nowadays everybody is going to configure this EIGRP. It can be run on the Cisco routers, say, as well as on other routers like the Juniper also. So this is definitely an advantage of the EIGRP you have got, and this is about the the theory part. You can say an overview of the theoretical overview of the EIGRP, and all these things you will get to know about the CCNA course also here, and also the CCNP Enterprise. Now let's configure it practically, because without practical configuration, without hands-on, we will not be able to get a proper grasp on this EIGRP or any routing topic. So, I am taking the routers, say the PT router, or you can take other routers as well. For now, for this demo, I am just say configuring 2 routers for now. And now take to say PCs. You can take loopback also alternatively, but I am taking PCs to connect to the Ethernet. Now, first let us configure quickly the IP addresses. Interface serial, and in packet tracer you have to give the clock rate. Say 192.160.1, 550. I am giving the default mask, you can change it also. And on Ethernet, say 10.0.0.1 here, and let us configure the quickly the IP address on the other router as well. Say 192.168.0.2. Address say 20.0.0.1. Let us configure EIGRP now. Now go back to the config mode, and here you are, router space EIGRP, and give question mark. You have to give the autonomous system number. Remember 1 to 65535, that is the range. So you give say 10. So this should be unique. This should be 10, and this should be same in other router also. It cannot be different. And the network, there is a 192.168.0.0, and you can use the wildcard mask here, but it is not mandatory. So I am not giving it for now. And network 20.0.0.0, that is the local network you have. And then go to the router 0 now. Router EIGRP and 10, the same ACE number should be there, because it is not the process ID, it is the ACE number. Network then 192.168.0.0. As you see, we have got the adjacency come up for the EIGRP. And the 10.0 network. So now you check the route with the show IP route. You can see that the directly connected networks as well as the D. D is for the diffusing update algorithm 20.0, that is the EIGRP, and you have got this is the cost EIGRP, that is not the cost, you can say the metric value, and 90 is the AD value. Because it is internal EIGRP, we are designing it inside the autonomous system, so it is 90. If you are going to configure the external EIGRP between the different A's, the AD value that is 170, and there is another AD value for EIGRP. You have to know this EIGRP summary route, that is the AD value, that is 5. So EIGRP has 3 AD values. And let us go to the other router. Show IP route, and here you go 10.0, that is also the route. So we have got the route of the EIGRP. Alternatively, you can filter it out like show IP route, and only I want to see the EIGRP. You can do it. So I am not seeing the directly connected networks now, only the EIGRP route. Also show EIGRP and give question mark. So in packet tracer it is limited. Show EIGRP, say let me see neighbors, but I think show IP. Let me see EIGRP, and yes, you can see interfaces, you can see neighbors, topology table as well as traffic. So let us say neighbors. You can see the EIGRP neighbor, that is the other router 192.168.0.1, and this is the hold time 11 seconds. This is the uptime how long it is running. This is SRTT, the round trip timer, and RTO, and the count and the sequence number. Now, in case of the, this is used for the troubleshooting. Okay. Now, show IP EIGRP, let us say topology, and you can see in the topology table you have got the, say, the successor routes. This is very important. This is a separate topic that I may discuss on some other day, because the successor, feasible successor, it is a different thing. It is a base route, it is mainly called the successor route, and the feasible successor is the backup route. If the successor route fails, then the EIGRP will calculate the feasible successor. So, it has all the successor routes, and everything is passive, means everything is active, everything is running fine. If some route is shown as A, means active, means some route has gone down and EIGRP is calculating for the other routes. Alternatively, you can see the show EIGRP interfaces as well, and you can see all the Pearson interfaces and all the statistics. So, main is a show IP EIGRP neighbors, and it is a show IP EIGRP topology. These things are used to troubleshoot. So, this is about the basic EIGRP that I have shown you, the internal EIGRP as the IGP protocol, IGP, internal gateway protocol within the autonomous system. But external gateway protocol, that is a very big thing within the, say, across the AS, or we can inject the outside route to the EIGRP, like the OSPF route we can inject, BGP route we can inject, that is a different thing altogether. So, that is about the basic EIGRP configurations that you can configure here, and EIGRP has a lot more features also. If you go for the advanced configuration, it has the variance feature, which actually does the unequal cost load balancing, because it is a very unique feature in the EIGRP. And to know more, you have a special offer going on your bottom of the screen. Get flat 30% off on any course today from the Indian Institute of Cybersecurity when you enroll today, and you have to just fill up the form that is actually available with this, and fill up the form and grab this offer, and it is valid till the 9 p.m. tonight. So, everybody watching this webinar should grab this offer right away. So, CCNA, CCNP Enterprise, all these courses, they are very much covered with the EIGRP. You should know the EIGRP even for the CCNA, because CCNA doesn't have the EIGRP in details, but if you do not know this protocol, then it is incomplete, because if you only know the OSPF protocol or the link set protocol, but you do not know anything about the advanced distance vector or anything about distance vector protocol, then it is an incomplete thing, because in production environment definitely EIGRP will also be there. So, definitely you have to study for these EIGRP protocols for your certification, for CCNA, CCNP certifications, and definitely I think everybody should grab this offer right now, and you should enroll for this course right away, because not only as a student you will get this offer, but also you will get a lot of opportunity for the placement, as well as the internship also we offer, that definitely you can get a hands-on experience that will be very helpful for your career as a network engineer. And as you know that in network engineering till now, this OSPF, EIGRP, these are the main enterprise protocols that you run in your enterprise, and BGP, ISIS, all these protocols are run in the internet backbone or the ISP level. So, to work on the enterprise networking, definitely you have to get very hands-on experience and exposure to this EIGRP protocol. So, that is it about the EIGRP overview for now. I think you have got a good understanding of this protocol, and you will be able to configure it, and also this knowledge will also helpful for your certification goals as well. So, I thank you all for watching and joining this webinar once again. I will come with some new topic next time. Till then, keep studying and bye.